Right, this is electromagnetic induction. We've got a galvanometer here, which is just a very, very sensitive ammeter. The spot in the middle goes one way if you've got a current in one direction, and the other way if you've got a current in the other direction. And I've just set it to an appropriate sensitivity so that we can see the effect of the demonstration here. Now, this is just a normal copper wire. There is no power source in this circuit. It's important to remember this here is just a measuring device. That there is quite a strong horseshoe magnet, and as we can see, if we move the wire up, down and up through the magnetic field, we get a deflection on the spot. If we do it more slowly, we get a smaller deflection for a longer period of time. Alternatively, you can think of it like this. We can have a loop of wire here, and if I move the loop of wire into the magnetic field, we get a deflection one way, and if we move it the other, we get a deflection in the other direction. On the other hand, you can also move it in like this, and move it out in a different direction like that. Same effect occurs. Now, you can think of this either as the wire slicing through the magnetic field lines in one direction and the other, or you can think of it as follows. We have a loop of wire here, we have a loop of magnetic field lines here. Magnetic field lines always form closed loops, so these loops and this loop at present are not linked. The links of a chain are so called because they link with each other. We're going from a situation where the loop of wire and the magnetic field lines are not linked to a situation where they are linked. We can say that the magnetic flux linkage is increasing or decreasing, increasing or decreasing. We must change the magnetic flux linkage in order to induce an EMF and hence a current. These two things are equivalent because in order to change the linkage, we must make the wire cut through the field lines, going from outside the loop to inside the loop. Okay, so much for that. What we're going to do is we can also use a coil of wire. This coil has 240 turns of copper wire on it. We can also change the magnetic flux linkage through this coil by using a magnet. Shall we stop there?